Connecting. There we go. All right. So this talk is about error boundaries. Error boundaries is new in React 16, which is new as of like a month ago. So why do error boundaries, right? Like who cares a lot anyway? So in the past, JavaScript errors inside components used to corrupt React's internal state, right? And it would cause React to emit cryptic errors about like what the next render is going to be like, or it would just cause inconsistent state things. And it would be very tricky to debug and figure out even what went wrong. So these errors were always caused by an earlier error in the application code, but React didn't really provide a way to handle them gracefully in components, so it was hard to recover from them. So enter this new API, component did catch, which allows you to create an error boundary. Pretty cool stuff. That's the only GIF in the slide because I'm not cool enough. I tried. We have a GIF aficionado here at Benzinga, and I didn't get consulting time with him, so I apologize for the lack of GIFs. So okay, when a JavaScript error in part of the UI shouldn't break the whole app, we want to employ this, right? So to solve the problem, React uses this error boundary concept, right? So error boundaries are React components that catch JavaScript errors anywhere in the child component tree, log those errors, and display feedback UI instead of the component tree that crashed. So error boundaries catch errors during rendering, in lifecycle methods, and in constructors, and like the whole tree below. A class component becomes an error boundary if it defines the new lifecycle method called component did catch. So like generally though, I think people are probably going to use this to refer to like a component called an error boundary. But according to the React docs, they want it to be that like any component that defines component did catch can be considered an error boundary itself, which is a reasonable approach. But you know, I have a personal agenda to push React towards like higher order components and composable things as much as possible, and so that's where the component comes in. So this is from the React docs. I want to walk through a little bit how this kind of looks and how it's set up. Can you guys see over there? Oh, okay, cool. So so this is the class. You have a constructor. It's all pretty standard stuff, and then it has its own internal state for whether or not to show an error. So we have a branch here that is the thing that you do if the error happened, and otherwise, you know, most of the time you just render children, right? So it's kind of like transparent in that manner. But the key thing is this new component did catch part. So this fires. I'll talk about when this fires, but anyway, this fires when there's an error, and so all they're doing is setting state for has error equal to true, and then they put in here, and I'm going to talk about this too, how we solved this problem when we implemented error boundaries. They put in a little line here to show you that like this would be a good place to log out to whatever your analytics server is, or if you're collecting any of this data about the error stuff. So this is our code that I pulled out of our app. This is Flow. Like I said earlier, we're moving from Flow to TypeScript against our will, but that's life. I killed it. How did I kill it? There, we're back. Okay, so I'm trying to move my screen here so I can see more. So basically, it's all pretty standard stuff. We have some types that we're defining. None of this really matters. This is a lot of the meat of it. So very similar to what you saw before. We collect error and this thing error info. That's the type that you saw up here. It's just it has a component stack in it in a string. Okay, and then you create a you have a render method such that it's kind of wrapping the component, right? So you see here and down there. Oh, you can't see my mouse. Let's see. I'm like mousing. You can't see my mouse. Pointer. Look at that. Okay. So you see here that the error boundary is sort of wrapping the error message stuff. And this is all inside of that if this.state.error. So this is identical to what React shows. And then like normally you just render children, but we have some other stuff in here that we want to render. I'm going to show you what this looks like at the end, but I just kind of wanted to set the scene for that. So this is the overarching way that you can think about how the API works. Of course, if you wanted, as a prop, you could pass to error boundaries to the error boundaries component special like override thing that you wanted to show. So you know, we're not really doing that in our case because what we want to show, it turns out, is just like the call stack. We want to show an error that's like going to be something, because inevitably what's going to happen is a user is going to call us and say, I'm having this problem. Hopefully, if we set up our analytics stuff correctly, we're going to be like way on the case before they pick up the phone, or maybe they wouldn't even pick up the phone. But the point is, people like to have something to say, like instead of just, we've had lots of problems in the past before error boundary where someone's like, the app just, it's spinning, it's just the loading, spinning, I don't know what it's doing, and that's confusing for people. So at least to say something is a little better than nothing. Okay, so so the component to catch method works just like the JavaScript catch, right? But only for components. So only class components can be error boundaries. So that's because it has the lifecycle method that it needs to hook into. So in practice, most of the time you'll want to declare an error boundary component once and use it throughout your application. So that's what I was just showing you, is we made this class called error boundary, and then like throughout our application we're like peppering it in, wrapping it. So there's like very little surface area to including this new thing into our application. It's just kind of like a thing that sits on top. And for us anyway, the way we're using it now is that only the big stems, and I think we all have these in our applications, like only the main things of the application are wrapped in error boundaries right now, although there's no compelling reason that other components couldn't also use it. But we're trying to like segment things off. So to the like highest levels. So note that error boundaries only catch errors in the component tree below them, or components below them in the tree. So error boundaries can't catch an error within itself. So you have to be careful when you're writing the error boundary code to be as defensive as possible. But we all write in JavaScript, so we know all there is to know about writing defensive code. That was a joke. You can laugh. It's okay. Yaka yaka. Okay. If an error boundary fails trying to render the error message, the error will propagate to the next closest error boundary above it. So this is like very similar to how just regular catch works in JavaScript. So I want to show you a live demo here. Does that work? Kind of. CodePen, but where's the sauce? Where's the oh. No. Yeah, it is. They're a bunch of jokers. You know, this thing happens in I have a screen on my laptop that's above it's like above the rest of them. And if in Windows there's this UI bug where if what you're trying to show is so
Windows still thinks it's on the other one.
It still thinks it's above. So there's literally no way sometimes with some applications there's no way to do it. I don't know. Anyway, moral of the story. This is a little thing that demonstrates. So okay, so here are two counters inside the same error boundary, right? So it crashes when the counter gets to 5 after I click. I'm going to click up to 5 on one of these. So then this is very similar to what we do, right? It just puts out the stack trace. Something went wrong. On this one, though, each of the little counter components has their own error boundary. So that one failed, and of course this one failed too, but this kind of like sibling component is able to survive, which is really fantastic. If you've used React before, you understand how amazing this is and how much of a life changer it could be. So back to the demo. Is it going to work? How do yes, question, please.
Is this intended for like the end user, or is this really more for like internal development stuff? Like,
you mean is it for like library writers and things?
Yeah.
Yeah, it's absolutely intended for the end user. Yep.
Okay.
So us simpletons writing applications, it's cool because it allows us to be a little more careful about what the interaction is between different components. So I'll talk about that in a second. Like how Facebook found this to be useful, because yeah. So yeah, kind of to answer your question actually. So where should I put these? So the granularity of the error boundary thing is kind of like up to you. You can wrap it at the top level components like I was describing, and then display like some generic something went wrong message, just like server-side frameworks often handle crashes. But you can also wrap individual widgets in error boundaries to protect them from crashing the rest of the application and pass in what that corrected state should look like. So you're always operating under, that's why I was saying you could pass in a prop that it would render instead of this.props.children. You could pass in your own thing to the error boundary that it would say like, you know, if I have a couch and one of the cushions catches, then I'm going to render like a placeholder cushion to use. Yeah.
So I have like an example that's just optimized.
Great.
So I have this like side project where there's this app that in one pane at the end it displays a PDF using like PDF.js,
Mm-hmm.
some like React wrapper on it, and every once in a while it has a bug. And right now in previous React it would result in this like unanticipatable behavior because it's like a huge library and PDF is complicated.
Yep.
Instead of having the whole
And you don't have control over it.
Right, yeah, it's a big library. And instead of having the whole thing crash, I can just replace that pane with a message like, oh, this PDF is bad. You know, click here to open it on your computer.
Exactly. Yeah, and then the click here to open it part would be specific to that one use case, and that's fine because it's just a thing you can pass in and you can compose it together. Yeah, that's a beautiful.
Like building an error handler.
Yeah, exactly.
And
Yep.
just to be clear, you can't just use try catch and render because the subcomponents don't actually render until you return from render. Because what happens is you're giving it the JSX tree, and then later on, React is going to inflate it. So before, you literally had no means of catching third-party errors in lifecycle and render methods. So this is a new thing that you can do that you couldn't do before.
This is an important like implication moving forward for React, and it's an important thing to be aware of because the behavior is going to be a little different now. So as of React 16, errors that were not caught by an error boundary will result in the unmounting of the entire React component tree. So they debated this decision at Facebook. You know, like, is it better? Is it worse to leave the corrupted UI in place or like just render nothing? And they decided it was better to do nothing because think about like with Messenger, if you had, which they're using React for, right? If you had some corrupted state, it could lead to you sending like a message to the wrong person or something. Or like like a banking application or something like that where you know, you end up making like a bum transaction or something like, or we have a stock trading platform, right? We got to be like careful about stuff like that. So it would be better in those cases to just like render nothing than it would be to try to like resolve by itself. So that's where error boundaries come in, is a way to give you a chance to declare how you want it to resolve if there is a problem, knowing that there could be in these kinds of cases. So like yeah, that's kind of what I wanted to say. So React 16 prints all the errors that occurred. This is a kind of just a thing to be aware of. React 16 gives you the this stuff out to the console.errors out to the console, even if the application accidentally swallows them. So in addition to error messages in the JavaScript stack, it also provides component stack traces, which is really cool. So now you can see exactly where in the component tree the failure has happened. So there's a transform here that will allow you also to get a Babel transform. I'm not really sure what it does. We don't use it ourselves, but while I was researching this talk, I found it. That will allow you to get the line numbers in actual files as you're going along. So that's a kind of a cool thing new to this. So I want to talk a little bit about configuration too with Git Sentry. So Git Sentry is it's a very, very popular. Is anybody here using Git Sentry? So apparently it's not that popular, but I know it's pretty popular. Okay, it's really good actually, and I'm going to show you. Yeah. Yeah. I'm going to show you a little bit of how this works. So basically, it logs things to a centralized place where you can go look it up later and get alerts for and emails. You can assign with Jira. You can do all kinds of cool things. So there's this thing. I guess I'll skip some of this. If you're not familiar with Git Sentry, then it doesn't necessarily apply to you. If you are and you're watching this talk later, you can read the slide. But generally speaking, I put some stuff in here about the basic API for the Create Raven middleware thing. So I want to show you that now. So check this out. All right. So this is an error that Rob made. Cannot accelerate to 88 miles per hour. So we can see a lot of things about what was going on here. These are the different times he logged this event. If we go to details, it's going to show us. So this is Rob. Don't spam him. Here it has some things that they call breadcrumbs, which are like things that people did in your application prior to getting the error, which is really cool. So this has been ridiculously diagnostic for us when we're trying to troubleshoot an error that a user has. And the error boundaries thing makes it like 10 times easier, because before, if there was a bug that the error boundaries would now catch, but before error boundaries, it was really hard to like recover from that and figure out what went wrong. And very often, like the app could even like crash or get into an infinite loop, and we wouldn't get any of this stuff logged to get Sentry. So these are some actions that we had in our application, and then here you could see we got exception, could not accelerate to 88 miles per hour. We have his user agent, he was on localhost, his ID, IP address, name, version. This is the version of his browser, but we also somewhere in here will have the version of our application, so we can look on GetSentry and see for all versions of the application that are like 1.12.5, show me the errors that people are getting, so that you can filter out things that you've already fixed in the past. You can also, there's a really cool system in here for marking errors. But anyway, without making it too much of an advert for GetSentry, one thing that's really cool that this middleware does is it allows you to poop out some state. So this is some like serialized state from our application, and you can see here like these things are diagnostic for us when trying to troubleshoot an issue. You can decide with the middleware what things you want to log and what things you don't care to log. But the point is that you can pass some information along here that might be useful for recovering some of the work you need to know to reproduce the error later. Because often that's the problem, right? Is sometimes people have a weird bug and you don't know how the hell they did it. And being able to see what there's something corrupted in their React. This is the Redux tree, right? Straight from the Redux tree. So being able to see that something was corrupted in the Redux tree is actually pretty valuable. So that's another thing that this gives us. Okay, I apologize for how clunky this is to go back and forth with the thingamajings. Present. Okay. Okay, so that's that. So John was talking about it a second ago, but why not use try catch? I think like the main reason is the one he mentioned about the error happening. Like the error has to happen before you could even catch it. So there's kind of like a loop there that becomes problematic. But also another thing I'll mention is that like it's imperative if you do it that way, right? You're saying like do this, but check this, and if that, then do this, and instead of saying like this is what I would like the state of the world to be, which is how I think pretty much everything seems to be moving this. I mean, back-end services are certainly moving that, like with Kubernetes and other things. And front end is doing the very same. We have enough technology to write more declarative UIs. Why not do it? So it's much better to say like, button than it is to say like try showing the button, and if you can't show the button, then do this error, and it becomes problematic. So yeah, using error boundaries kind of like hits the sweet spot on the declarative nature of React, if you know what I mean. So I didn't make a like that's all folks slide, but that's all folks. Any other questions or comments? Yeah.
Is there any,
Oh, go ahead.
okay, is there any cost to React managing all of the error boundaries?
Yep. So as far as I understand, it's a class component. So it's another, because it has a lifecycle method. So it's another component in the React tree. And if you're averse to those, then I guess the answer would be kind of. But other than that, it's fairly transparent, because if you look at what it's almost always doing, it's almost always just like passing through and like displaying this.props.children. Like there's really no calculation going on there. So there's mounting and unmounting like there is with any other component, and there are all the things that come with that. But ideally we'll have thousands of components in our application, and adding another 5% of error boundaries if you're using them in the way that I was describing is really minimal. Now that's if you're using the component style that I was displaying in this talk. But if you're using the like sort of impromptu style where you just define component catch on a class component, then nothing really, because the API is already going to call that function if it's there, if you have a catch anyway. So it's not like it's not going to call it if the method's not there. If it's there, it's going to look for it anyway, because this is how React is wired now. So now that things are the way they are, I think if you use that method, then there should be no cost, only gains. What could be better than that? Any other questions?
So, just like statistically, what are the nature of the errors that are being
Yeah. So let me try to show very quickly.
Do they fall into like categories?
I'm not sure what you mean.
So that goes in a little bit to my example I brought before. A lot of the times, like you should know when a component's going to fail. Like ideally, you're going to know. And then, like previously, you wrap it in a try catch. But sometimes you don't know because you're getting like user data, or you're getting third-party data, or you're using some big library. So there's like that added risk, and that's what this really comes in handy.
Yes.
I guess what I'm getting at, another way to phrase the question is, when you ultimately fix the error, what is the nature of what you're fixing statistically? Where are the errors coming up? What
Oh, I see.
type errors?
Yeah, they can be type errors. They can be, in fact, the example that I had from our own application, which I'll show you in a second. It's all the standard stuff. It's all the things you're used to. Type errors is certainly one of them, but there are, I mean, anything that could break the tree, anything that could throw inside of a component. So, like on Rob's example, he just threw a string, but anything that can error otherwise is fair game to break the component. Now, it might not always. Like you can have an error in a promise sometimes, or there are like plenty of ways to have things throw that don't kill your application. One thing that I'll mention, actually, I forgot to say something that's moderately important, perhaps, which is that they say in the documentation that like be careful when you, or not be careful, but they mention like, hey, when you use this, you might find things that error in your application that you didn't know were erroring, and you didn't see it before because it's momentary and it like goes away, or the problem resolves itself and you didn't notice. And sure enough, today, like 2 hours ago, I was sitting and I found something that was exactly that. It's something that's been erroring for a long time, but it's like that. It goes away really quickly. It's like one render frame because somebody built some synchronicity. I think that's one of the problems that is going to happen with React 16 is that once they keep going with this async rendering stuff, like you'll find in your applications that you built synchronicity into it without meaning to. You like in your head you're like, oh, this is going to happen, and then that's going to happen, and then that third thing is going to happen. But the way that React is rendering moving forward is not doing it now because it's still on the experimental API. But the way that they're going to have it going is you won't be able to depend on that necessarily.
All bets are off.
All bets are off. So you have to build with like the asynchronicity like up front and like defensively catch for these things. That's why things like TypeScript and Flow are so damn important because it's really tough to like manage all of that null checking stuff in your in your noggin. Anyway, this is just it's just a random view from our application, but this is what our error catcher looks like. I wired the button and the button throws an error, and it's just a type error, cannot read property month of undefined, okay? So what we did in this case, so this is an error boundary that's our application is built of, it's like composed of these like widget things. So what I did is, let me throw up a couple of these just for good measure. So like, if I kill that widget, then the rest of them are functioning fine. And in fact, we did it in such a way that we can even close the component that's having trouble. And for us, this is a gigantic thing because before, that error that you're looking at now would have crashed the whole application. And now it's fine. From a user's perspective, it's like not that scary. And we built in the Raven stuff, so like right now to this like that thing I just did logged to the whole state tree to Raven both times I showed it to you. And as a developer, I can go back and look into that and try to figure out what happened there. And the user is like, so we took the users from going from like getting flame hot and pissy when as they should because they're paying for a product and it's not working, and all the way to like they can resolve the error themselves, and yet we still have the information we need to go find out what happened and fix it in the future. So this is everything for us. The async, the speed, the 20% speed boost, and all the other things that come with React 16 are great. But this is for me, this is the biggest feature that we got. It's really groundbreaking to be able to do this. Maybe it should have been that way from the beginning or something, and I'm just a sucker. But anyway, that's the talk. I'm going to cut it there. Okay. So next, I'm gonna close all these things. Oh, I should stop the OBS thing momentarily.